Hello everybody. This is the notes for section 5.2, Algebra 2 Trig, talking about solving quadratic equations. So solving an equation means you're figuring out what is that x value that makes that equation true. We're going to use Pythagorean Theorem a little bit also because it's got x squareds in it, just like all quadratics do. But as it says up there in that fancy font, there's two types of equations to solve quadratics. One are a little bit easier than the other ones, but the biggest difference is one of them has just a single term that has the variable squared, and that's what we're really going to talk about in this section. So something like x squared plus 7 equals 50. Okay, there's that one x squared term. It could look something like x plus 3 quantity squared minus 7 equals a weird number. It's 9.5. Let's make it 50. But again, there's just this one term that has the x squared in it. When it's in that form, you solve it a certain way. That's what we'll talk about today. The other type is the equations that we looked at yesterday. There's a term squared. There is a term to the x power plus a constant. Okay, when you have those two different terms with different powers of the variable, there's a different way to solve it. It's a completely different method. We'll talk about that in section 5.3. Okay, so you got to make that distinction because there's different methods to solve it. So today we're looking at these things up here. To do the solving here, you need to get that term with the variable squared in it. You need to get that alone by itself on one side of the equal sign. Okay, and then once you have that, you can use these properties here. So what this blue box is saying is if you have an equation where it says x squared equals a number, and that number is greater than or equal to 0, kind of important, you're going to get two answers, positive and negative square root of a. So essentially what we're looking at is something like this. X squared equals 25. You take the square root of both sides. What you get is x equals, now the square root of 25 is 5. Okay, it's called a principal square root. When you just take the square root of a number, you get a single answer. It's the positive answer. But when you are solving an equation where you have taken the square root of both sides of that equal sign, you're always going to get those two answers, positive and negative. Very important, you have to do this every single time. Whenever you take the square root of both sides of an equation, always two answers. So, some properties of square roots that you might be having to use. If you've got the square root of a times b, you can separate them. It's still multiplication, but I just messed up the writing here. But it's still multiplication, but the square root of the first factor times square root of the second factor, and same thing with division. Square root of the numerator over square root of the denominator. Those might come in handy when you're solving these things. So let's look at this couple of examples here. To solve for the variable, this is the term with the x squared in it. There is no other term with the variables in it, so we need to get this term by itself. So we're going to add 23 to both sides. So we get 7x squared equals 126. Now we need to get the x squared part by itself. So the x squared is being multiplied by 7. So we're going to cancel it out by dividing by 7. So we get x squared equals 126 over 7. Okay, not a great number, but it's okay. Now that we've got the x squared by itself, now we can take the square root of both sides. So we get x equals positive and negative. And I'm okay with this. 126 and 7 are not square roots. I don't think there's any factors of them that are perfect squares. Doesn't seem like it, so this will be the answer. And you can get the approximate answer on your calculator. I'm not going to pretend to know what it is. So, but just do square root of 126 over 7, you get the approximate answer. But again, positive and negative. Okay, the second example on the right looks a little bit more complicated. Now, you could FOIL this thing out, this x plus 5 quantity squared, but don't. You're making more work for yourself. This is the term, okay? there is a quantity of x that is being squared. We need to get that by itself. So the first thing we're going to do is divide by 64 on both sides. X plus 5, quantity squared equals a 289 over 64. All right, now, what we're going to do here is just think of this x plus 5 as a single variable. We need to get rid of that square. So we're just going to take the square root of both sides. You're just going to be left with an x plus 5 on this side. Now, you took the square root of both sides, so you are going to get your positive and negative. Square root of 289. That 289 seems like a perfect square, but I'm not remembering it off the top of my head, so I'm getting the calculator out. 17, that's what it was. Okay. 64 is a perfect square, so square of the top, square of the bottom, we get 17 over 8. Okay, we still have not solved for x. We still got to subtract 5. But now, we got two numbers to subtract 5 from. We got x equals a positive 17/8 that we're going to subtract 5. And we've got a negative 17/8 that we're going to subtract 5 from. You have to do both. And so now it's just a matter of getting common denominators. That's going to be 40 over 8. Same thing over on this side. So negative 23/8 is one value of x. Here, this is going to be the 48. We're subtracting that, so a negative 57 over 8 is the other value of x. There is our two answers of x. Okay? It's really all the same work, but there is that extra step in here. All right. Go ahead, hit pause, copy this down. This is a problem that we'll start class with. I hope everybody has a good night, and I'll see you in class tomorrow.